Just sitting on the sideline.
All right, so this is Pythagorean Theorem, right? Obviously, the biggest and most important thing from this specific section is a squared plus b squared equals c squared. Okay? What's important about the letters? I mean, the numbers. Can they go anywhere?
No, it has to be A, then B is the hypotenuse or whatever.
Switch it. C is the hypotenuse, right? So A and B are interchangeable, but C has to be the hypotenuse. So obviously, the a squared plus b squared equals c squared is the most important part from that. You're learning new, but we're still simplifying radicals, which is where we got to practice. So when you look at number 1 or 1 and 2, it says find the values for x and then do the sides form a triple. How do you know if something forms a triple?
They equal each other?
Mm-mm.
But you have to add 3 sides.
They all have 3 sides. A squared plus b squared is always going to equal c squared in these. But what makes it a triple? What kind of numbers? Whole numbers. Okay, they have to all 3 be whole numbers. Okay, you can't have any decimals or fractions in order for it to be a triple. So if you look at number 1, this is 9 and 12 and x. So I could do 9 squared plus 12 squared equals x squared. How do I know the x goes on the side by itself? Sure, because it does. Yeah, but why? Why do I put the x by itself? Because it's C. How do I know it's C?
Because it's on the other side of the equal sign.
It's a cross. It's on the other side of the equal sign. But what makes x go there? It's the hypotenuse. It's opposite the right angle. So what's 9 squared?
81.
What's 12 squared?
144.
And then 144 plus 81. 225. And then I square root both sides. And I get the square root of 225. So what goes into 225? How can I break that down? 5 and 45.
I put 116.
It works too. Yep. Wait. 116 and 2? Is that what you said?
Yeah.
No, 2 doesn't go in there.
It's not an even number, Alejandro. It's the odd.
What goes into 45?
5 and 9.
5 and 9. What goes into 9? 3 and 3. So this would be 5 times 5 times 3 times 3. And the rule is every 2, 1 would go to the outside of the square root, right? So there's 2 5s, there's 2 3s, which means the square root of 225 is actually 15. How did you get it?
I just added like 9 and 12.
Nope, can't do it. Doesn't work that way all the time. You can't do it that way. Hey, is this a triple? So are the side lengths 5, 12, and 15 all whole numbers? Are 9, 12, and 15 all whole numbers?
Yeah.
Yeah, so is this a triple?
Yes.
Yeah.
Yes, it's a triple.
Oh, that's how you find out if it's a triple?
Yep.
I'm not gonna, when I
I'm
saw
not
the
gonna
triple
lie,
on the thing, I was like, what is that?
How do you find out if it's a triple?
All of them are whole numbers. Which is said on the video that you guys were attentively listening to.
No, I did watch it. I just didn't
All right, number 2. What number goes by itself?
20.
The 20. So this would be x squared plus 8 squared equals 20 squared. What's 8 squared? What's 20 squared? It is 400.
It's just 2 times 2.
God bless you. So I get x squared equals 336, right?
It's 36 and 6.
Okay, you could do square root. So 6,
Not 36 and 6.
6 and 56, right? And then 2 and 3. And then 2, 28, 2, 14, 2, 7. So when I write all those out, there's a 1, 2, a 3, a 2, a 2, a 2, and a 7. So this is, again, this is like where you guys tend to make the most mistakes. Be really careful when you're breaking this down. Doesn't matter in what order you break that down, your ending answer should all be the same. So there would be 1 pair of 2s. I can bring a 2 to the outside. There's the second pair of 2s. I bring another 2 to the outside. There's not a match for the 3, so the 3 is going to stay underneath. And there's not a match for the 7, so the 7 stays underneath. So then I multiply together the numbers on the outside, that's 4. Multiply together the numbers on the inside, and that's 21. So x is 4 root 21. Are the side lengths 4 root 21, 8, and 20 all whole numbers?
Yes. No, it's not.
No, as soon as you get that square root, you can't simplify, right? That's not going to be a whole number. So are these a triple? All 3 of them have to be.
What other third one are you talking about?
The 2 that they gave you at the beginning, so the 8 and the 20, and then the one that you find. All 3 of them have to be whole numbers in order for them to be a triple.
That makes sense.
Questions? So again, just like before, you get some, like if you're doing this on your quiz and you can at least set it up for me, I can give you some points. You give me nothing, obviously I give you nothing back. That would not get you points on a quiz.
Oh, not on a quiz.
Yeah. All right, so we're going to finish. So if you'll open the notes, we'll complete this part tomorrow. So quick review of what was covered. We did your a squared plus b squared equals c squared. These are your common triples. So these are the ones that you can memorize and will help you, especially on standardized tests. If I gave you a triangle and the side lengths were 3 and 4, you don't even have to do any work to know that the hypotenuse is 5. The benefit of these is eliminating all that work. Okay, so these are your common triples. Then you work these, example 1 and example 2, and we are here at the converse of the Pythagorean theorem. So if you remember from conditional statements, converse flips them. Converse flips them, okay? The if becomes the then becomes the if. So if the initial Pythagorean theorem said, if it's a right triangle, then a squared plus b squared equals c squared, this is the reverse. If a squared plus b squared equals c squared, then I know the triangle is a right triangle. So we're going to classify all these different triangles, and the first is as a right triangle. If a squared plus b squared equals c squared, it's a right triangle. Okay, if it's not a right triangle, then it's either an obtuse triangle or an acute triangle. So theorem 8.3 says if c squared is greater than a squared plus b squared, then the triangle is obtuse. And theorem 8.4 says if c squared is less than a squared plus b squared, then the triangle is acute. So now you can classify them in 3 ways. Right, if it's equal. Obtuse, if c is greater, c squared is greater. And acute, if c squared is less than. Okay, so this is what's going to happen. You're going to get given 3 side lengths this time, and it's going to ask you to classify it. So your answers are either right, obtuse, or acute. Okay, the first thing you have to do is find the biggest side, because that's your C. You have to have that one be alone, right? So if I look at A, 5 is the biggest one, right? So I'm going to say 5 squared has what relationship, because we're going to fill that in, to 3 squared plus 4 squared.
Are you supposed to solve it?
Yep. So 5 squared is?
25, 9, and 16.
Good. And 9 plus 16 is? 25. I heard it. So what's true about 25 and 25? Are they equal, less than, or greater than?
Right.
They're equal, which makes this a right triangle.
Jordan, all you gotta do, friend, is just put in the ABC. No, I'm Miss Chris Weiser Jr.
Yes. So you're going to get the biggest one, right? The biggest one goes first by itself. And then you're going to figure out if when you square that, you square it to the other 2, but you're going to add the 2 smaller squares together. If they equal, it's right. If they're less than, it's acute. And if it's greater than, it's obtuse.
Right?
I thought that said 2 squared.
Oh, no. No, I got you.
I was like,
All right, so look at
If
B.
it's less than, it's acute. If it's greater than, it's obtuse.
Yep.
Obtuse.
Right, yeah, like think of it as bigger, right?
Acute.
All right, so 5, 6, 8, what's the biggest? 8. So we're going to do a squared first equals 5 squared plus 6 squared.
64, 25, 32. She was about to ask. the
I
question,
was,
but now
actually.
you're giving me the answer.
So what's 35 plus 36? 61. Is 64 equal to, less than, or greater than 61?
It's less.
Greater than, it's
Oh my god.
greater than, which means obtuse.
I think my brain's shut up, Jordan. Instead of trying, what are you doing? Just writing down the answers. Thank you.
Lisa just asked a good question. She said, does it matter what order the 5 and the 6 are? And the answer is no. The C has to be first and by itself, but the other two doesn't matter the order. If you want to do small and large, it totally doesn't matter. The most important part and what will mess it up is if you put the C with an A or B. So the biggest one has to go by itself. So now look at C. I've got square root 10, square root 5, and 2. It's not as obvious what's the biggest anymore, right? So there's two ways to look at this. One is try to approximate it. So square root 10 is close to what perfect square? 10 is close to what perfect square? 9. It's a little bit bigger than 9, right? So it would be a little bit bigger than the square root of 9. What would be the square root of 9? 3. So it would be bigger than 3. Does that make sense? So this could be, it doesn't matter what the value is yet, but it could just even be like a 3.1, as long as we know it's bigger than 3. How about square root 5?
Wait.
So we're approximating it. We're just trying to say, what perfect square is that near?
4.
Right? So 5 is near 4, and the square root of 4 is what? 2. So the square root of 5 is going to be bigger than 2. Let's just say it's 2.1, okay? All we need to know is that it's bigger than it. We're approximating root 5. So we're saying we don't know what square root 5 is, but I know square root 4 is 2, right? And 5 is bigger than 4, so square root 5's got to be bigger than 2. I'm going to show you two ways to approximate it, okay? That's the first. So now looking at these three numbers, which is the biggest?
2, 3.1.
The 3.1, which means root 10 would go on the side by itself. Does that make sense? So once we approximate, you're looking at your numbers again and you're saying, okay, because 3.1 is the biggest of those three numbers, root 10 is C, and root 10 is going to go on the side by itself.
So you put 3.1 because like 3 times, I just said like 3
Be-
times 3 is 9 and then that's.
And it's a little bit bigger than 9. Yep. Okay, so if that's hard, then after you square them, you can still look at the numbers. So let's say I get to this point and I don't know what root 10 is squared. I don't know what it is squared. But I go to square them. What's the square root of 10 squared?
It is squared of 1.
Which would be
10.
10. What's the square root of 5 squared?
5.
And what's 2 squared?
4.
So what's the biggest of those?
10.
Still 10. So that's the other way you can do it. You can either approximate it as the roots, or you can square them all and then find the biggest one. It doesn't matter which way you do it. So we just did that this would be 10, this would be 5, and this would be 4. So 10 has what relationship to 9?
It's greater than.
Which makes this triangle obtuse.
This is easy. This is.
It is super easy.
Why don't you easy and I'll do 2? I'll do 2 actually.
No, never say it's too easy. Never. Yeah. Yeah.
So why did we have to do the other part, the 3.1 and 2.1?
There's two ways. So if I had, let's say I had square root 15, square root 11, and 3, for example, right? There's two ways to figure out which of those are the biggest. One is approximate it. So this is closest to square root 16, right? Which is 4, but that's a little bit less. So let's say this is 3.9. This is closest to square root 9, which is 3. This is a little bit bigger. That's like 3.1. Now I can identify which one's biggest by that. The other way you can do it is square them all, because I'm going to have to do that eventually anyways. I'd get 15, 11, and 9, and then figure out the biggest.
So how could
You would either have to estimate root 15 to be a little bit less than root 16, like 3.9, or you would square them all. And I'd get 15, 16, 25. Now I know that one's the biggest one. Does that make sense?
yes.
Okay. So you can do it either way. You can either approximate it by trying to figure out the root, or you can square all three of them and then pick the biggest one there. And then compare it to the sum of the other two. Alright, so this is all three on one side. That's all this is. Okay? If they are equal, then it is right. If C is less than, then it is acute. And if C is greater than, then it is obtuse. So for me, I think less than is cute, right? It's smaller, so it's cute. So that's why it's easy to always put the C on the left. You always put the one that's by itself on the left. And then bigger would be obtuse. So if it's greater than, it's obtuse. Yes? Yes? Okay. Homework's open. Open it up so you can work on it.
Can I first answer?
Mm-hmm.